Hi everyone, welcome back to my channel. I'm Mel. I'm an Uruguayan biologist that is in Germany doing her PhD, and on the side I have this YouTube channel in which I interview scientists all over the world. I invited Nicky, a PhD student in robotics at the University of Bonn, the same university I am at right now, and she's gonna tell us all about her cool background, the cool stuff she's doing, and just talk about robotics and what it is and what can we do with that. Hi Nicky, thank you so much for coming. It's very cool to have you here and I think this topic is awesome.
Hi, I'm really happy to be here.
So to start, tell us a bit about your background.
So when I was a teenager, I actually wanted to be a theater actress. But then my parents told me I needed a real job. So my second choice was something STEM related. I wasn't really sure why, because I like chemistry since I was a child and I was doing very well in high school physics. I just ended up applying for the most prestigious technical institute that we had in the country, which was Technion, and I picked the degree that had the highest acceptance requirements. Not the best decision-making process, but I was 17. So I was doing my bachelor in electrical engineering and physics, and luckily for me, I actually enjoyed it. After that, I worked in industry for several years. I started like as a software developer, worked my way up to algorithm developer. I was working in computer vision, which is exactly what I wanted to do, but I felt like my knowledge was a little bit too shallow. So I decided to get my master's degree in computer science. I studied in Switzerland, in USI. Was really good, really fun. The plan was to finish with the master's and go back to the industry. But I ended up enjoying my thesis and research part a little bit too much and started thinking, well, maybe I should do like research for a little bit longer. And here I am doing my PhD in robotics.
Wow, what a cool background! And what can you do within the area of robotics?
Robotics is a very diverse domain. Like you have mechanical and electrical engineering, you have computer science, you have even like material engineering, control theory stuff, but even things like cognitive sciences and psychology when you actually consider how robots and humans should interact. The end goal for all of those very, very different disciplines is to like design and assemble and deploy machines that will help us carry out certain tasks.
And what is your favorite, or in what are you specializing, or like what kind of work do you do?
My favorite part actually is writing code. I like it almost as much as I guess. I prefer like more of a lower level languages like C and C++, even though they are kind of less convenient to humans, but they allow you a greater degree of control over how instructions are executed on the hardware. And for what I'm researching, and because I'm working actually with robots, writing code is a really big part of it. What I'm focusing on is long-term localization for robots in indoor environments, and basically every complex task that you can think about that we can give to robots to execute. It requires the robot to kind of understand the world around it and know where it is and where it needs to go and where things are relative to it. This is knowing how to localize in the environment is basically the foundation on which we build more complex tasks. And for robots, especially when environments are changing all the time, it's really hard to adjust, and they cannot do it as easily as we humans do things. Like, for example, door is usually open, now it's closed. It's confusing. Furniture moved. It's confusing. An office has been repurposed as a supply room. It's confusing to the robot, and while we can still somehow navigate despite those quite significant changes for robot and robot perception, this is very, very challenging. So how do robots observe the world? They have sensors like that can infer the range, so the distance, for example, to the nearest obstacle, and sensors like cameras that give you color information. And this sort of information is what we need as an input for robot perception, like building an understanding about the world around us. And the input from the sensors is basically a bunch of numbers, right? So distances to point in space that are the nearest obstacles. Even colors are encoded as numbers. So like dark color is gonna have like low values and bright color is gonna have high values. But how do we make sense out of this like soup of numbers and points? We start by clustering points, planes, lines together to shapes, to objects, understanding that a group of points actually belongs to a certain shape. And then we build a geometric understanding of the world, which is already better than a soup of points. But this is not enough. Okay, so geometric reconstruction is something that can be done like for decades at least. But then a lot of things have very similar geometry and very different meaning, like tennis ball, crystal ball. You'd expect to see them in a very different context, right? So what we do to help robots understand where they are and the world around them is that we also add semantic information. So objects not only have like geometry and color, they also have a semantic meaning. This is a chair, this is a sofa, this is a crystal ball. And with this like additional information, robots have better chance to understand where they are. Because what we do is that we take this raw sensor input, we put it into structures that have meaning, that are distinguishable from each other, and this allows robot to go into a room and say, I've been there because I recognize this object, this object, this object, or it goes into a room and it says, I have no memory of this place.
Super interesting. And can you tell us some concrete example of some cool development that is being done in the field or something that you want to share with us?
So even though now I'm in a research position, I'm an engineer at heart, therefore like I'm more drawn to research that is kind of a little bit more product maybe oriented. And for me, the most exciting thing, happening in robotics right now is actually the work done by Boston Dynamics. So from like their humanoid platforms like Atlas, who can do parkour, or their leg platform Spot that has the moves like Jagger, can dance with BDS. I've been following their progress for years and it's super inspiring. I don't know, for me it feels like maybe something big will happen in my lifetime and maybe I'll be part of it. So it's the best thing you can hope for, I guess, as a researcher and an engineer.
Yeah, that would be amazing, and the applications are endless. And this is the time to be doing this.
Robotics has applications in many domains. Healthcare to manufacturing to even like domestic appliances. The goals are basically, relieve humans from repetitive tasks. Like, I bought a Roomba. Who actually likes mopping? Another goal would be, to reduce the risk for people, whether it's like, dangerous jobs like bomb disposal, if you can do it with a robot, great. Or it's like monitoring environments that are actually harmful to people, whether they're like toxic, have high radiation, stuff like that. If we can delegate it to robots, again, great. The other aspect relates directly to improving quality of life for certain populations. For example, people have problems with mobility, are now looking into the usage of exoskeleton and external skeleton that would support them in like everyday activities that they do and help them mobilize themselves. Stuff like, bionic limbs and, just help people live a little bit better. My message to people that are like in the beginning of their STEM journey is don't give up. Like if you cannot get in through the door, get in through the window. For example, when I graduated from my bachelor's, it was really hard to find a job as a person who doesn't have experience. Like everyone wants experienced people, right? So I basically took a job that paid very, very, very little. But that was a start. I gained very valuable experience there, which allowed me to then apply to other positions and other places. Basically, I tripled my salary within 3 years. And of course, I got to do things that were more interesting to me. So take the opportunities, these few opportunities that are available to you, take them, use them, learn as much as you can, and then go forward. Okay? Sometimes we cannot go to where we want to go in one step. Sometimes you need intermediate steps. There's just no shame in taking those intermediate steps.
Totally, persistence is key, passion, but really having patience. It's difficult sometimes, but it's great advice. And those were all the questions that I had for you today. Thank you so much, Nicky, for being here with us. It was a pleasure to talk to you.
Thanks for having me. A shout out to my colleagues, lab mates in Technion lab, University of Bonn. I hate all of you, but in a very affectionate way.
And thank you for your attention. If you like the video, I invite you to subscribe to the channel. I also have a Patreon account in which you can support the channel, and see you in the next video. Bye bye.